Hi, everyone. Thank you for joining us today. We will begin the webinar in approximately 1 minute. Hi, everyone. My name is Robert Davis, and I'm the account manager for the nanotechnology division at TAPI. I'd like to welcome you to today's webinar, Sustainability versus Nanocellulose in Diverse Applications. Today's speaker is Dr. Joyce Kashuk. If you have any questions throughout the webinar, please type them into the Q&A box at the bottom of your screen, and we will address those questions at the end of the presentation. Today's webinar will be recorded, and the recording will be available on TAPI's website soon. The webinar will be held in accordance with TAPI's antitrust policy and procedures, and the full policy is available at tapi.org/antitrust. I will now turn over the floor to Dr. Tiffany Abbott-Ball for an introduction of today's speaker.
Great, thank you, Robert. Before I get started, I'd like to just say this is I've had this position of TAPI Nano Webinar Chair for the past 2 years now, and this will be my last time chairing. And this is also a good opportunity because Professor Joyce Kashuk will be taking over this responsibility. So it's been an honor and a privilege to have this role, and I really think we're in good hands with Joyce as well, continuing in this work. And so now I'll very happily introduce our speaker, which we're very happy to have today, Professor Joyce Kashuk. She holds a PhD in physical chemistry from the University of Sao Paulo in Brazil. She worked as a postdoctoral researcher at Aalto University in Finland and the University of British Columbia in Canada. She has been a member of the TAPI Nano division since 2021 and a TAPI journal editor since 2024. Currently, she serves as an assistant professor at Wageningen University and research in the Netherlands. Her expertise includes processability, modification, conversion, and the characterization of biomass, wood, cellulose, and other biopolymers, ranging from the macro to the nanoscale for multifunctional and advanced applications. And with that, I give you the floor, Joyce. We're very much looking forward to your presentation today. Thank you for being here and for taking over this responsibility. I super appreciate it.
Thank you very much, Robert and Tiffany. It's a big shoes to fill, but I'm super glad to be the new webinar chair. Yeah, I think I want to start this presentation saying good morning, good afternoon for those that are in the afternoon or in the morning. It's a big pleasure for me to be part of this division. So yeah, I have like a kind of created like a discussion in terms of like what is sustainability, what kind of a research we've been doing with nanocellulose. So for that, I kind of plan in a presentation. I don't know why it's not going on. Okay, so I plan a short presentation about myself. Not going to be anything totally different than Tiffany said, but I also wanted to introduce a little bit about Varna University. And also, I will go through some concepts of like sustainability and circularity, and then finalize with like some examples of non-cellulose applications that we were working with, and also some current work that we've been developed in the group. Yeah, so about myself, I'm Brazilian, so I did my master's and I did my PhD at the University of São Paulo. After that, I moved to Finland for a visit and research during my PhD, and then after that as a postdoc, and then I had the chance of like doing holding a visiting scholar position at the University of British Columbia. And since December 2023, I'm an assistant professor here in the physical chemistry and soft matter chair group. And this is our campus. This is Varni University. It's quite unique, and in the sense that, like, for instance, this campus has less than 30 years, so it's quite new, quite bright, and it's very well located. It's very well recognized on food technology and also agriculture science. But then what makes this university quite special is because we have a mission as a whole university. So our mission is like how to explore nature to improve a quality of life. And how we do that. So we have basically a few areas of research. So for the past 100 years, we were working to solve problems and shape a more sustainable future. And we research biodiversity, climate change, circularity, bio-based economy. We have researches on how to improve the quality of food and how to actually increase the productivity of food. And recently, we are also included into one of the research areas, artificial intelligence, where we can use this tool as a complement for all the research. And our university, when I say our university, I say it as a whole, we have several actions to have more sustainability and be more sustainable. And this is shown in numbers. So for instance, we have the green metric system that measures how the university is sustainable. And last December, we were appointed as, for the 8th year consecutive, the most sustainable university in the world. And for that, I think this is the main place, the right place for me to be, as I'm working with a bio-based product, a bio-based material. But I also generates the discussion, what is actually sustainability? So to start this presentation, I decided to look it up. What is actually sustainability? So I went to the Oxford Dictionary, and then I saw the definition. So by the dictionary, sustainability is the ability of maintaining at a certain rate level, avoiding the depletion of natural resources or maintaining an ecological balance. So in my point of view, this is my perception, this definition says that we all the materials, all the energies, and all the products that we take from the nature to use, we need to use in a balanced way that we cannot interrupt the ecological balance. Of course, this is just a definition. It's a modern definition. Sustainability are being used in several other ways, but all similarly with a similar meaning. One example of that is how United Nations define sustainability. So I think most of us have already faced the Sustainable Development Goals, but United Nations have defined that sustainable development is that one that meets the needs of the present without compromising the ability of future generations to meet their own needs. But what I think that's quite beautiful in this definition, in this movement, is that they don't see only as aspect of what kind of materials or what kind of resources you're taking out for nature, but also as a whole. So all the actions are in terms of economical, societal, or environmental. So all together, all these three pillars together can be generating a great society and a more sustainable generation. Of course, this is a discussion, very extensive discussion. And when I was preparing to this presentation, I found this paper, and I really liked it. I really enjoyed the reading of this paper. Discuss a little bit more further about the concepts of the sustainability. So if you wanna to give a look about how the term sustainability evolved during the years. So it's quite interesting to read. But here we are talking about materials. We are talking about non-cellulose materials. So I will kind of define what I consider a sustainable material. But before defining this, I wanted to just make a resolve that's last year I attended this conference, and there were this amazing lecture, and then he was like talking about that there's no actually sustainable material. There is a material that's more sustainable about compared to something that we are using. So basically what he said is that we sell the word, the concept that we are developing sustainable materials, but we wanted to use these materials to replace something that's already like in high performance, so how we can do that? So we have like some targets that we wanted to achieve for these materials. So for instance, we wanted to have a renewability. We wanted that the process of producing this material be energy efficiency. We also want a durability of these materials. Then in the end of the life, we wanted to recycle them, and especially we wanted that this be safe for our health, mainly because most of these materials are in contact with our organs, like skin or even internally. And then when you evaluated these definitions of what is a more sustainable material, we look into non-cellulose, and then we see that we have most of the features. And so we have we can produce them from renewable sources. We have we can biodegradable, and then we can make a compost process with them. We have a lower energy process compared to petrol-based materials, and they have no toxicity, and they are safe for our health. So yeah, okay. So if we take this nanocellulose and replace in any technology, we are going to have sustainability. But I think one of the key factors that we are doing as researchers is go a little bit beyond, because these sort of materials, they have so many other functionalities, so many other features that we overlooked. So in my research and with my collaborators, we tried to develop to try to understand how the different versatilities, the different features, the different properties can be used and as in favor of the technology, not only as a replacement, but also as a provider of maybe long-lasting life, or even another feature that's only happens when you use this sort of materials. Here, I will give like a step back. I will talk a little bit about another concept that's also related to sustainability. That's the circular economy. So I think most of us that we work on this area, we already like use this speech that, yeah, we are doing circular economy. We are changing the raw material to decrease the amount of residual waste on our technologies. But I still think that there is much more than only replacement. So one of the what I like the most of this image is that shows all the steps that we can actually improve to make more circular and an economy more green. So for instance, we can, instead of like just replace, we can design our products, and we can design our technologies using the properties of this non-cellulose to increase the properties. But then again, most of our research are done like a kind of, okay, let's replace, works, let's move on. We actually don't understand very well what is going on and what's the features that is coming to that. So yes, as I said, I think one of the main goals of like our research is like can we apply this non-cellulose and reinvent the circular economy and sustainability using their properties. So I'm going to show some examples of what we are doing. So starting, for instance, with solar cells. So I think most of us, everyone knows that solar cells produce green energy. So we use the energy of the sun. They convert the energy into electricity. There is no emissions of the pollutants, and it's quite high efficient. And it's like almost, I'm here in Netherlands, so almost all houses has like one panel, solar, at least one solar panel on their houses, and it's one of the most cheap source of energy that we can have. These materials are fascinating for me because they are kind of very efficient, and it still has room for improvements. Even though we have like a commercial stated, we can even change the structures and make more efficient or more sustainable materials. But one thing that is also a concern for us is that if we take care very well of these materials, of the solar panels, they will last for around 25 to 30 years. When I say taking care very well, it's like taking care of like how they are installed, how if there's no anything breaking or anything that's like interrupting the circuits. If everything goes very smooth and then panel is very well confirmed, after 30 years they will die naturally. But of course, when you're applying, depending on the circumstances of the installations, things can happen, like for instance in the image, like the panel can break and then instantly they are killed. And this is a problem because what they will do with these panels? Most of the panel is composed by glass, and most of the time it's not possible to recycle these panels, and then it's creating a different, like a big pile of waste, and then this kind of is a problem. So this picture, it's a picture for some of my collaborators in Finland. They are researching, their focus are on solar cells, and they were doing several research in different areas, but to actually make more sustainable and use bio-based materials to produce the solar cells. So for those that are not familiar with the technology, solar cells are, I always make the joke, the solar cell is a type of a sandwich. So it's two substrates, and then the middle has a lot of layers, and these layers together, they generate the energy. So in my case, when we were working on this project, I was focusing on substrates. So basically I was producing non-cellulose papers. And here I think it's not new. Non-cellulose papers are semi-transparent, they have a translucent, and they have this very interesting feature of scattering the light. As you can see in the picture, when you're close to the film is transparent, but when it's a little bit forward and it's more hazy and such. And this happens mainly because of differences between the bulk and the surface. The voids created within the structure of the film. And then when you mitigate how this film is formed, different optical properties can be observed. This type of a research as a replacement, using this non-cellulose as a replacement for solar cells, is something that's very well known in the literature. But the thing is, most of the measurements done for this sort of technology, for this sort of application of non-cellulose, is done with the material on a flat surface, and then the measurement on parallel with it. So these measured, like the lights are measuring in a right, like in a directed angle, and it's not actually what happens when you're applying a solar cell. I don't know if you noticed, but most of all the solar cells, they have an angle of 45 degrees when they are installed, and this is actually to help to improve the amount of the time that the sun will reach that surface. So we decided to actually evaluate what happens with these films when we bend them over. So this parameter is quite straightforward. the light was in a stationary station, and we were bending the films in different angles and evaluating the transmittance. So what we notice is that when we reach like angles higher than 30 degrees, the transmittance of these films drops very fast. And the reason of this is because there's more reflection than actually scattering inside of the light. So this is something that's need to be concerned of the when you're doing this using this as substrate. But also, when you see this, you think like, okay, so this means that you cannot use the Nanocellulose for solar cells. Actually, there's a few features that is very interesting to use on when you're using Nanocellulose that you cannot use when you're using glasses. For instance, different opticals and mechanical properties can be obtained very straightforward with very straightforward modifications. But I think the most interesting part is because you can kind of sort of predict it how these properties can be done. So when you understand how is the suspension, how is the stability of the suspension, how many nanofraction of the suspensions have, you can actually have like and also how you've done the film, you can change the properties of the film. This is quite unique compared to when you're using for solar cells. But of course, we need desirable properties. For instance, as I said, and we need low refractance. We need to have a mechanical strength. The roughness needs to be very low because these materials are not conductive, so we need to kind of coat a conductive layer on the top. So we still have a room and how to improve. Another feature that's quite interesting is that we can use these nanocellulose films as holders for other light management properties. So for instance, one of the main factors that makes the solar cells die is the own degradation regarding the UV exposure or infrared exposure. So as you can see here in this image, there's a red area and a blue area. So if you focus on the blue area, is only that area that actually generates energy inside of the solar cell. All the rest only heats and degrades the compositions. And so all the rest, all the red area, all the wavelengths in the red area, they will kind of kill the solar cell. And in this sense, using nanocellulose films can be an advantage because in a straight way forward, we can add it, like for instance, lignins, nanoparticles to block the UV and increase the efficiency. Of course, I think everyone here already saw, like in any presentation, that you mix the lignin with the non-lignin with nanocellulose and gets like the UV blocking. This is quite interesting. It's quite straightforward. We can have like a high transmittance, even though we have like the UV blocking. But of course, we need to understand if this is actually the right method to do it. So the next project we did, we kind of understand how these materials would behave if they would be exposed to light for long periods of time. Because for solar cells applications, it's necessary to have stability in optical properties and mechanical properties. So what we did, we exposure different films containing lignin or not to a sunlight for 45 days. A sunlight simulator for 45 days. As you can see here in the images, when you observe the colors, there's little changes in the colors. The UV capability is maintained. So even here in the bottom image, there's like an example that there's a polymer that was degraded when the lignin was not found. But then when we move to the transmittance graphic, we see some differences on the transmittance, on the materials, and this could be like said that it's a lot, but if you stop to think, this experiment was performed in an environment that was simulating 10 years of exposure in sunlight. So considering that feature, we have like a very high stability of these materials for solars, for optical properties. And for that reason, we can use this as a UV blocker for solar cells. Unfortunately, we cannot use these materials as a substrate in themselves because during diverse photodegradation of the system, the mechanical properties of these materials decrease very fast. So this kind of generates changes in the structure and makes them very weak. And for that reason, you cannot use this as a substrate by themselves. But again, we can use this as a filter. So we can use in top of the solar cell and as a filter, and then we can increase the time of the solar cell. But of course, then you ask, but the reason is not to remove the glass and make it recyclable. So if we manage to increase the lifetime of the solar cell, we also increase in sustainability of the process. But lignin is not the only one particle bio-based additive that we can add it. So I had a colleague while I was in Finland that he was working with these very cool films, beautiful films, Rafael. He was extracting the dyes from the peeling of the red onions. And then he was studying how was absorbing in the surface of cellulose and in textiles. And surprisingly, these materials have a UV blocking. So what we did, we grabbed some samples and then we did an evaluation of the stability on solar cells. So we predicted how long these solar cells would work if you had like a bio-based filter on the surface. So here is part of the results. We just submitted the paper. So hopefully in the future, soon in the future, you can access the whole paper. But basically what was done was like submitted the solar cell was evaluated. We had like a commercial filter as a reference. We had a filter that we had the lignin, and then we had one with a red one. As you can see here, our prediction shows that the red onion CNF film, they have a very long period of life. And with this, we can increase the sustainability, we can increase the lifetime of the solar cell. And then for that, we can say that we produce a more sustainable solar cell. Okay. But nanocellulose love water, and all this applications of all the solar cell applications it's kind of inviable because when cellulose absorb the water, then all the properties are kind of lost. But how about if we use this love for water as an advantage? So this is what we did in this paper, in this project. We kind of play around with like how water interacts with the cellulose. How we did membranes, mixture membranes with carboxyl groups and sulfonated groups. When they are mixed together, they had a different water uptakes, and as you can see here in the bottom image, changing the temperatures, that water you can have a different type of for amounts of water that's absorbed by the filter. And then the good part of this is that mixing both of them, we also play around with the conductivity and the ion exchange conductivity of these membranes. So these kind of membranes can be used for proton exchange membranes and using as a fuel cell and also generate energy. Of course, the conductivity of these membranes are very low. As you can see, non-cellulose, as you know, non-cellulose doesn't conduct any ions, but we can use these materials, sort of materials, to decrease the amount of polymers that we can use it, or combine with other types of molecules that increase the conductivity of these materials. Okay. Now I'm gonna start like talking a little bit about some projects that we are developing currently in the work. So I will start one that's non-cellulose in built environment. I think there is a lot of people in our community that has been discussing the integration of non-cellulose in cement. and this is quite interesting because you can decrease the amount of the CO2. As you can see here, the construction industry is responsible for 1/3 of the consumption of the CO2 and consumption of the resources, but also 7% of the amount of the CO2 emissions in the environment. So there's different ways of approaching. So this is project that starts with Patricia. Patricia was a master's in my group, and she was developing 3D bio-based products. So why 3D bio-based products for construction? So if you use only the technology, the 3D printing, as you can see on the left the image, you can already decrease the amount of resources that you use to create a house. But if you manage to do that with bio-based products, you can have more sustainability in the application. So in the right image, there's like a house that was built. I think it's in Italy. I'm not sure. But basically what they did a 3D printing with rice husks and natural fibers. And then they actually managed to do like a very well designed house. The issue of this technology is that we need to improve the printability. So her work was basically to use different bio-based products. So like in her work, she developed how to print oyster shells mixed with alginate and nanocellulose. And this is quite hard to do because, like, for instance, all the research and medical applications using nanocellulose, you wanted to have a porosity, you wanted to have a flexibility. And here you need to have like little porosity, but very hard materials. But also you need to have like a binder that glues everything together, and also need to be resistant to water. So there's a lot of challenges on that. So our first results were like that we actually managed to print some samples. We managed to print like some shapes, different shapes. But then when we evaluated the mechanical properties, we see that the nanocellulose actually made them softer. And this has also increased the water uptake. This could be something bad for buildings, but for instance, we could use for applications where you need to have a sort of softening to kind of generate a more stable environment. For instance, in roads. This project was recent the award with funding, so we are moving forward for the next phase. We are trying to investigate different materials, but everything starts with the project with Patricia. Okay, great. So coming back to the system, the circularity. Yeah, so far the things that I've been saying is like how to design, how to use, how to replace. And this is quite important, but also I think one topic that sometimes we escape from our minds is how to make our raw material more sustainable. So it's an excellent opportunity to use non-cellulose, but I think we need to give a step back and try to think about like how we can improve the quality of our raw materials. So what I have in mind is that first of all, we need to rethink our sources. Most of the non-cellulose works that I've been doing so far, we use wood-based non-cellulose. And now in my group, we are trying to use different biosources and different agriculture sources as well to produce different fibers. This not only affected the fact that you can have higher quality of nanocellulose, but also can have different functionalities for them. But also we are rethinking our process. So I think this is something that everyone should actually think, because as you know, nanocellulose is a multi-step process. So we start with the lignification, then we go to the modification, and then finally we get a nanocellulose. This can be crystals or can be nanofibrils. I work mostly with nanofibrils, but you have several steps, several processes, several chemicals, And most of the chemicals that we use are not that well, they are not that green. So this is the challenge that my student is doing. So we are trying to use a different biosource. So we are using rose wastes. It's a very good source of cellulose. It has like almost 50% of cellulose, but also we are trying to develop a more green oxidative process that we can not only treat the cellulose to remove the lignin, but also modify the surfaces. This is an ongoing project that we are still developing, but basically what we did, we mixed up the biomass with different organic acids and hydrogen peroxide, and then we performed the reaction till we have this dignified carboxylated cellulose, and then we microfoliate it to produce our nanocellulose. So our initial results shows that like the cellulose, the fiber of the roses are quite like smooth, it's quite beautiful. And then we can get nanocellulose without any organic acids, but when we mix the organic acids in the mixtures, we have more amount of nanocelluloses, more stable nanocelluloses with more different sizes and different carboxyl contents. So this is an ongoing project, and this is one of the few questions that we are doing. So like how we can transfer this method to different biomasses. So we are trying to start off with other biomasses, but also we wanted to improve how we can improve this functionalization on the cellulose, because this functionalization of our cellulose is still very mild. So we wanted to have a more carboxylated cellulose, how we can manage that. And also we want to see how we can apply this nanocellulose and which kind of applications we are gonna do it. So this is more or less what we are doing in the group. Yeah, there's mostly no specific conclusion on that, because I think everything that we work it's related to sustainability, is related to how we can make our work better. But I also wanted to end this presentation with a kind of invitations. If you didn't submit your abstract for the TAPI Nano conference that's going to be held here in Girona, I'm going to be there. So if you want to chat about it, and if you want to present your work, and we can create a great discussion on cellulose. The deadlines for abstracts are extended by the 13th of February, so we still have time. Here is my contact, and I really thank you for the attention, and super excited about the discussion.
Thank you, Joyce. Great talk. Just a reminder that was put in the chat, if you guys that are online and have listened to Joyce's talk, if you have any questions that you want addressed, we have plenty of time, as Joyce said, for discussion and for some questions. You can put them directly in the chat, and I will basically read them out to Joyce. You have an opportunity also to put them anonymously if you want, so it's all good. If you're shy, don't be shy, ask your questions. Maybe I'll just get started. Joyce, thanks a lot. You spoke a lot about sustainability, what it means, and how we can look at that question that in terms of the materials that we work with. I was just wondering if you're looking at any specific metrics to actually understand how sustainable, for example, nanocellulose is produced from roses versus from another source, and if you can just comment on that.
Yeah, so so far, as I said, it's an ongoing project, but also one thing that we wanted to understand is like if in this process, because we managed to get removed cellulose up to 29%, I think. There's charges in the surface of the cellulose. This is great. But we don't understand exactly what happened during the process. So we don't know what actually happens with the lignin. If, for instance, if we remove the lignin, if that creates a valuable molecule. Because, for instance, you can generate vanille or other molecules from the extraction of the lignin. So we are still trying to understand that. But I think because it's a quite mild process, shows very good perspective for other biomasses. So right now we are trying hemp. and has similar results. And what is interesting, if you change only the type of the asset, you have a totally different behavior on the properties. So this is kind of a very green method sort of thing. But I'm not sure if I respond your question correctly.
No, I mean, it's nice to understand that like you can tailor the kinds of materials you get, of course, with the kind of biomass you use, but also the chemistry that you use or the extraction processes that you use. I was just wondering, so more like things like thinking about a carbon footprint or something like that, or a water footprint, I forget what that's called, like those kinds of metrics. So let's say you produce a bunch of different nanocellulose materials from different what appear to be more sustainable sources.
Yeah,
What decides if it's actually
I think what decides is like
sustainable, basically?
yeah, yeah. I think what decides what makes the process more is how much it's available to do the process. So, for instance, while we were like in Sweden and Finland, there's a lot of wood, a lot of forest. So it's makes sense to work with wood cellulose. But here in Netherlands, most of the biomass is produced from agricultural wastes. So like a kind of we have like for hemp, it's one of the wastes that we have, like flowers. Flowers is like tons of per days that they waste. Because during the process of like sorting the flowers, they need to cut the edges, but also if the quality of the flower is a little bit lower. So it's kind of incredible how much biomass, and most of them is just grinded and thrown away in the fields back. So we can use this as a raw material. But also there's a discussion, this is more in govern why, to kind of create connections with countries, more warmer countries, because this is, I think, it's a problem with Europe itself, because countries like India, Brazil, they have a more resources and more variety of biomass. And I think this is also something that's kind of how we can connect it with the distribution. There's a discussion internally of the fact that buying the biomass is not sustainable, but buying the product for the biomass is sustainable. So, for instance, if we produce a nanocellulose that actually can have a functions, very high functions for application, and actually shows in the product, it's good to kind of develop the process in a different country and buy the products after. So it's a question how to do it in this sense. Yeah, and also if you stop to think, like cellulose itself is not non-cellulose itself compared to the fiber, the cellulose fiber, it's already more expensive. So yeah, it's a good question. It's hard to answer that as well.
Yeah, thanks for that. I think maybe I can so again, those of you in the room, please, if you have any questions, put them in the chat. But I can just ask maybe another question, something I think about a lot. Also, what's your thinking about, is all biomass worth that contains cellulose? Does it give you a good
I think
nanocellulose?
I think it depends of like how much cellulose there is also in the content, because there's, for instance, I used to work.
But what about the quality of the cellulose?
Yeah,
like, not just so of course you need a composition that makes sense,
but I also, like, for instance, I used to work with coconut fibers. They're incredible for composites because the lignin has a lot of surface charges. But I think like in terms of quality of the cellulose itself, it's very poor because there's little and it's very poor. I'm not sure if you're seeing. I'm sorry to interrupt, Tiffany, but I think
I don't see that. Oh, do you have something in the chat?
yeah, I have something in the chat. I thought you were able to see it.
Okay.
There's
I
one
don't. I only see no. I'm looking, but I only see Robert's comments. So please answer the questions from the audience. Great. I don't see it.
Okay. So yeah, there's
Great.
one. Are any challenges in terms of ability in lignin versus onion extract? I think for sure lignin is more prominent, especially because most of like and not only in paper industry, but for instance, in Brazil, there is this company that produce second generation ethanol for sugarcane. And again, lignin is the residue. So they take most of the advantage of the biomass to produce energy, but in the end, lignin is the most prominent. I think the beauty of working with onion extracts is because you can, like for instance, their initial project was for textiles. So they were developing dyes for textiles. And then we realized that was like a great opportunity to do as a UV filter for solar cells. So I think this kind of a multidisciplinary, it's something that's valuable for the thing. Yeah,
I see
so
the chat now, by the way. If you want me
So the second question is
to go to the
about
next question.
the fiber length of the roses. So yeah, so the physical we are still like I don't have the data right open here, but the fibers are I think they have a little bit more, they are more longer, but also they are more finer compared to wood. I think this is the main difference of the cellulose from biomass with wood. Because wood, you have the whole 3D structure, and then you need to put in more effort to break down. So when you use a biomass, you can actually use this process, more a mild process, and produce like high quality nanocellulose. But I have one of my curiosities, like after we develop and understand a little bit better how we are doing the process, is how this would be working on wood. So this is kind of a future goals as well. Okay, so I still there's one question about like industrial partners. I think in our stage we are still trying like we are trying to understand the process. So far we don't have any industrial partners. Yeah, so the quantity of cellulose in your biomass. So flowers is around, or roses are around like 48% of cellulose. But then this varies from biomass to biomass. So it's kind of something that you always need to check before starting. Yes, the nuts can nanocellulose be used as a packaging industry, particularly to improve mechanical properties? Yeah, so this can be done. One of my students is trying to kind of develop like some packaging. Actually, two students are developing some packagings. One is more towards film with like more hydrophobic properties using this nanocellulose, and another one is trying to use more like absorbent packaging sort of things. Again, I'm not sure how would be related comparing to non-cellulose from wood, but this is something that we can look it up for us. Okay, so how can we bring the cost of production of nanocellulose down so that the market adoption would increase? Or rather, how can you determine the value proposition of nanocellulose to promote adoption and the current high prices? Yeah, so this is a good question. I really think, and but I think there is another solution instead of like, because right now the technology it has a high cost, but there is also a reluctance of the market for those projects. So for instance, when you're applying, you're trying to use this sort of materials, and even for packaging, like nanocellulose for packaging is quite expensive. So when you try to use those, the consumer needs to understand the benefits of using that. And so we start with this change of mind of the consumer, and also trying to make the process more cheaper. And I think in this sense, I think the process that we are trying to develop, it's quite reasonable, cheaper, because we are trying we kind of combining two processes in one. But of course, this is still in the beginning of the study, so it's kind of, I'm not sure if it's viable to do in larger scales and this kind of stuff. Okay, what kind of solar cells are you expecting to use non-cellulose? is organic voltaic of silicon base. Okay, so there's a lot of research for perovskites right now, but also the type of solar cells that we were testing was disolar cells. These solar cells are quite impossible to do it because you need to have like a kind of the liquid, and then because the cellulose kind of absorb the liquid, so it's something that can not produce well the function. But I think organic photovoltaics, I already saw like some works of like non-cellulose using organic photovoltaics, but I'm not sure. Okay, so they behave more like a softwood or hardwood fibers. So this is a good question, and as I said, it's something that we are still looking on. It's different. The property is different, but it's mainly because of the structure of the biomass is different. How usual agriculture biomass grows very fast, so the structure is more loose. So I think would be something more towards softwood, but we still need to dive in on that. Okay, what are the typical pathways to produce sustainable nanocellulose compared to commercial kraft pulping methods? I'm not sure if there is there any. Maybe Tiffany, you could help me on that. Maybe I'm not sure if industrially we have any nanocellulose like more sustainable path compared to.
Sorry, maybe I missed the exact question. It was about.
Yeah, what are the typical pathways to produce sustainable nanocellulose compared to commercial kraft pulping methods?
I mean, generally, commercially, it's a pulped material, so it'll already be something that has been pulped. So basically, kraft pulping or whatever. You have your pure cellulose material, and then that's processed to give you some kind of nanocellulose, either nanocrystal or nanofibril. So it doesn't get away, at least as far as I know, commercially, it doesn't really get away from traditional pulping. That's usually the pulp material is a starting material.
Yeah, exactly. No, because I'm trying to recall, because I have seen several papers that they use in different, like for instance, it's quite expensive, but they use ionic liquids, or they use like dipeltetics, or there's like some variations of our method using with using catalysts. But I don't see anything actually being developed on a large scale. I know that for instance, for some technologies can be transferred, like for instance, there is some colleagues of us that they are trying to extract alginates using dipeltetics, and actually their residue is nanocellulose. So it's kind of they indirectly produce, but they don't use it. It's like because the molecule that they are looking for is totally different. So I think currently there's none. So yeah, I think there's no more question here, Tiffany.
Great. So if there's no more questions in the chat, then we're just around wrapped up for time. So thanks so much, Joyce. It was really interesting to see your perspective and your approach on sustainability and these kinds of interesting nanomaterials. And so with that, I mean, we can wrap up the webinar and say thank you, and looking forward to the next webinar where you will be chair, and
hope to
very
see
much
you
looking
all.
forward. Yes, guys, every couple months, basically, there's a webinar. So there's about 6 webinars every year. And usually, and I know this will be the case in the future, there's usually really top, almost all the time, there's top researchers in the field that are willing to share their perspective on these interesting nanomaterials, and sometimes non-nanomaterials, different things that they're working on related. So it's a really good opportunity to connect and learn from each other. Okay.
Okay, thank you
great.
very much.
Thank you so much, Joyce.
Thank you very much for all the attendance, and see you soon. Bye-bye.
Thank you, everyone.
Great. Take care. Bye-bye.